quick unboxing video for some PCBs that I have ordered from allpcb.com. It's a company based in China. Their prices are very competitive, but the quality of the goods that you get, it seems to be extremely good. So, okay, so the package is in front of me. You can see it's come via TNT, and it's ended up at Stansted Airport, which is conveniently my local airport. So anyway, I've already cut the pack open. I'll take out the box, and here it is. Fresh from All PCB, very nicely packaged. So it's a top speed PCB manufacturer. Well, they certainly are. I ordered these, I think it was Thursday just gone, and there was a slight problem with the files that I uploaded. So they let me know before I even woke up on the Friday. I fixed them on that Friday, and then they've got them to me by Tuesday. So it's a really quick service, even though it's come, you know, a quarter of the way around the globe. So that's brilliant. They're also, as I said, sent via TNT, and I didn't receive any additional customs duties to pay on these due to the value that was stated on the shipping forms. So anyway, let's open up the package. So here it is. Here's my PCBs that I've ordered. They're quite large ones. Now obviously there's larger and there's smaller, but these are what I needed. So this is actually a retro computing piece of kit. Obviously these will be prototypes, so I don't know if they're going to work yet, but that wouldn't be the fault of All PCB necessarily, or even likely. It's more likely the fault of me making a mistake during the design. But this is actually a replica of a board for a computer called the Dragon computer, which was made in the early 1980s. The board itself was made by a company called Compusense, and just recently I had a discussion with the managing director of Compusense, and he gave me his blessing and approval to remake some of these cards so that we could make them more common today, because the retro computing scene is still popular. If we can get more of these cards out there and get them working, then more people can use systems like OS 9 and some of the more high resolution editing packages on the Dragon 32 and 64. So let's open it up. So I've ordered 5 of these boards, and I think it came to something like $42 plus shipping. Now I know I said that the customs amount was lower. I guess that's because of the actual value of the items should they go missing. So that was handy. I suspect if I ordered a production quantity of these, they would be much heavier, and there would definitely be some customs or import duties to pay. But anyway, I'm really excited to see these, because I've been out of electronics for a long time, so this has been a bit of a labour of love doing this. I actually made the PCB design with a package called KiCad, which is a free piece of software, but it's brilliant. And so I laid it out to be as similar as possible to the original DragonPlus cards, as you can see. Although the routing, I routed all of the power rails manually to be virtually equivalent to the original DragonPlus, but I did let KiCad, or rather another auto routing program which is available for free, do all of the other interconnections. To be honest, it's amazing how easy it was to order the boards, and well, although I haven't tried them yet, and I'm still waiting on some of the parts for some of these. I need some through-hole connectors, but it's, well, already I'm feeling very impressed with the quality, and the customer service was great as well. I'd looked at the really high quality 3D views via KiCad, and to see it in front of you like that, it's just brilliant. It looks great. So I'm very much looking forward to actually getting to make up these boards. I've got most of the components, so I can get started. It's just completing it that's the problem. I'm also really impressed with the wires on here, because I was expecting much bigger holes, but they're tiny. It's just brilliant. You hardly even notice them, to be honest. So the board looks beautiful, and it looks like I've got more than the 5 that I ordered as well. So there we go. I've actually got 7 boards, which is great. I just hope they work. So that's it for my unboxing video for all PCB, and so far so good. It looks like I'll be using their services again. Thanks very much for your time, and thanks for listening. Okay, so now it's time to have a look at the schematic diagram for the project. So here you can see some of the main connections that will connect into the existing Dragon 32 and Dragon 64 computers. It's called the SAM chip, and just to the right of it is the relocated SAM chip from the computer onto the new board that we're building. The ROM from the computer will also be put onto our new board, and then here PL1 is a plug which will connect directly into the existing ROM socket on that board. Over here you've got another 64 kilobytes of dynamic RAM memory, and then over here there's a whole host of pretty complicated controlling logic, basically performing manipulations between this board and the main motherboard. Further up we go more towards the video logic part of the board. So here we've got the 6116, which is a mighty 2 kilobytes of video RAM. Up here we have an 6845 CRT video chip, which is just used to actually create a display. To the right of that, a character EEPROM. Over here some more clocking circuitry. And then up the top we've got some digital to analog conversion going on, where our logic circuitry is being merged into an analog signal, and finally jumper 4 is our output. Now we're going to look at how we lay out the PCB itself. So I've already laid the chips onto this diagram, and you can see the red and green tracks on here already. They are what I have already laid out according to the original board, as this is a reconstruction. You can see that all of the pins have a useful identification, letting you know what that pin is and where it's going to. And it's pretty clear and easy to navigate your way around this diagram. Now auto routing, and now in the past you would probably have had to route all of these links and tracks yourself. Nowadays you tend to just route the really important ones, like the voltage rails, get them at a suitable width so that they can carry enough current, and then depending on personal preference and how much time you've got, you either keep routing manually or you just set this auto routing program off and leave it. This actually took about 3 hours I think in all, and I've got a pretty fast machine, and it was also using the GPU to do the processing, so it's quite an intensive process. But all in all, I'm quite pleased with the results. It came up with around about 112 wires in the end, I think. That used to be a considerable expenditure, but nowadays, with much more efficient board production, wire count is not really as important as it used to be, apart from making boards more complex. And finally, here's a bit that I really like, the 3D render. So when you've put your board together and you've done all the routing, although you can't actually see it on this one, I think that's the colour scheme I've chosen, you can have a good 3D look around your board, check it all looks okay. And it's quite a faithful reproduction. You can check that all your writing's in the right place. If you'd used chips in the as the footprints, you'd probably see those on the board, but I have just used sockets and they're not showing up. You don't really need them to show up, they just clutter the image really.